Welcome to the Ep10 Infrared Learning Series. This episode, Ep10 Summary and Self-Test for Beginners. Can you read an infrared spectrum now? We will cover every key point section by section, then close with a checklist. Next, recap of 9 episodes. Congratulations on reaching the end of the beginner's guide. Ep01, where Herschel saw infrared light with a thermometer, to Ep09, comparing the two vibrational spectroscopy languages of ear and Raman. We have built a complete knowledge framework of infrared spectroscopy over 9 episodes. Next, knowledge mind map for the beginner's guide. 1.1 Overview of infrared spectroscopy knowledge system. 1.2 Quick reference of core knowledge points. Next, 10 self-test questions. The following 10 questions cover all core knowledge points of the introductory section. Basic concepts to spectrum interpretation with increasing difficulty. It is recommended to attempt independently before checking the answers. Question 1. Basic concepts: wave number and wavelength conversion. Next, detailed answers to self-test questions. Answer 1. Wave number and wavelength conversion. Kilonu equals fraction lambda equals fraction wave 0.0 times 10 caret minus 4. Text cm equals 2000 text cm $1. Next, recommended resources for beginners. 4.1 Online learning resources. 4.2 Recommended textbooks. Next, sound questions. If an ear spectrum shows no absorption peaks in the entire 4,400 centimeters range, what conclusion can you draw? A compound's ear spectrum has a sharp medium intensity peak at 3,300 centimeters. Is it OHACE or NEH? Finally, the drill actualists. Make sure you can recall each item. Episode U. Own sentence summary. Infrared light is electromagnetic waves with wavelengths 0.78 1000 micrometers. Mid-infrared 4,400 centimeters is the main battlefield for molecular analysis. Molecules vibrate like spring mass systems. Vibration frequency is determined by bond force constant and atomic mass, Hooke's. Only vibrations that change the dipole moment are ear-active. Among the atomic molecules are silent. The x-axis of an ear spectrum is wave number. The axis is transmittance. Peaks are evaluated by position, shape, intensity. C equals O, 1715 OHs, broad, NH, downward, are the 3 superstars of ear spectra. 10 CX. Each have characteristic frequencies. The core mnemonic helps remember carbonyl. The fingerprint region, 1,500-400 centimeters, is the molecule's ID. Hard, benzene substitution and long-chain CH are key. Systematic FI step interpretation. Overview: high-frequency region, double bond region. Fingerprint region, cross-validation. Air sees polar functional groups. Raman sees non-polar skeletons. They are complementary, not redundant. That covers the required stencil for this episode. Practice with real spectra on Fun, and continue with the next lesson.